Hello friend, myself Sanjeev Dwivedi. On behalf of Vidyalankar Institute of Technology, I welcome you all in this Java session. In this session, we are going to talk about the built-in data types in Java, typecasting concepts. So let us talk about built-in data types. Now, when it comes to built-in data type, first we have integer part. So from here to here, basically we have integer part, and these are floating points. And Java supports Boolean and character. Now, when first we're talking about byte, when we say byte, it will assign a memory of 1 byte, and this is the range of values that can be stored in that memory. A higher data type is short. It's normally size 2 byte. I normally we don't use short. If I'm talking about dealing a value in this particular range -32768 to 32768 we may assign a short data type. But normally what we do is we use integer data types. For all integer type operation that we see, integer in Java occupies size of 4 byte, which was not there in C. In C, C++, अगर आपने देखा होगा कि 32-bit system पे normal 16-bit system पे it occupies size of 2 bytes. Here it occupies size of 4 byte, and this is the range of values it support. So even higher range integer value, if we desire, then we can assign the data type long, that will occupy the size of 8 byte, and even higher range of values supported. So these are all integer data type that we have. When it comes to floating point values, floating point may we have float and double. Now the float occupies size of 4 byte. Obviously it will store some fraction numbers and sufficient up to 6 to 7 decimal digits. So what we call it as a single precision floating point value. Okay. And even higher range floating point value, if we desire to store, then we can make use of double data type that assigns size of 8 byte and stores up to 15 decimal places. Again used to store fraction number. Now the interesting point here is float is not the default floating point values in Java. In Java, if I simply write 3.4, this will occupy size of double and not float. Correct? So it is basically, it can be assigned to double. But if we want to assign this 3.4 to float, then we have to write the suffix f with it. So what you're supposed to remember is the default floating point values in Java is of type double and not of type float. So if we want assign float values, if you want to like something like this, float x equal to, if I want to assign this 3.4 to x, then it must be then it must have a suffix f to it. Now in C++, true and false when of the supported data type. So it doesn't support Boolean type. Java supports Boolean type. In C++, non-zero basically identifies true value and zero identifies false value. Here we are provided with Boolean data type that can take value of true or false, and the size is 1 bit. And yes, very interesting, when it comes to character in Java, the size is 2 byte, and it includes ASCII values, but along with it, it also supports. I mean, ideally, it supports Unicode character set. So Unicode character set, the first 128 characters are ASCII values only. So Unicode character set is a larger character set that provides you a lot of characters when it comes to implementing universal language like Java. So these are your built-in data types in Java. Now, when it comes to data type, there is a very interesting concept called as type conversion. Because if there is an operation that involves values of different data types, then there is some confusion, and we need to resolve the confusion. And for that, we are going to make use of type conversion. Now, what is type conversion? It is a process of converting value of one type to another type. अगर दो different data type एक साथ operation में, if there is an operation that involves operand of two different data type, then the type conversion will come into picture. See, if the two types of variables are not compatible, the type conversions are not implicitly allowed. Now, what do you mean by that? See, It basically the conversion of lower type to higher type or a higher type to lower type. If the conversion is from lower to higher, if I want to convert an int, if I want to convert, suppose there is something like int x equal to 10, and I want to assign it to some float. It will be done implicitly because conversion from lower type to higher type is done implicitly. But other way around, if there is something called as double p equal to 3.4, and if I want to assign it to some int x, I simply cannot write like this ideally, because there is conversion from higher type to lower type. So I need to typecast it using a cast operator. It's like p converted into integer and then assigned to x. This is how it goes. So if let's say in the example here we have m equals to 50, and if I want to assign it to byte, now 50 is an integer value, higher type as compared to byte, then I need to typecast it into byte and then assign to m. Similarly, m is integer. I want to assign it to long. So I'll convert it into long and then assign to count. However, in this case, m is lower type, long, count is higher type, long. So अगर हम ऐसा नहीं लिखेंगे, then to it is allowed, because then it is implicitly done. So lower to higher is implicitly done, but higher to lower is done explicitly using cast operator. See, typecasting is of two types. Narrowing, when I say narrowing, it's from higher type to lower type. And when I say widening, it's from lower type to higher type. The process of assigning a smaller type value to a larger one is known as widening. And the process of assigning larger type to smaller one is known as narrowing. Higher type to lower type. Now, we are narrowing it. Now, obviously, when I'm narrowing it, higher type to lower type conversion, there is a chance of losing precision. So if 3.4 converted into integer, it will be 3. So I have lost the precision zero point 0.4. Now, casting is necessary when value of one type is to be assigned to different type. It also be needed when a method returns a type different than what we need. Now, suppose I'm calling a function and it returns integer float value, but I want to assign that returned value to some integer. Now, it has to be explicitly typecasted it. Now, so this was about the primitive data types in Java and automatic type conversion and explicit type conversion. So remember, lower type to higher type. When operand of two different data types are in an expression, then lower type will get automatically converted to higher type, and we call it as widening. Okay, and higher type to lower type is explicitly done during a process called as narrowing. In widening, there is no loss of precision, but in narrowing, yes, there is loss of precision. So this was about typecasting. Thank you.